get started. I'm Jeff from Murideo and AV Pro Connect, and today we're going to be doing a short presentation on the Fox and Hound generator on behalf of the Catalyst AV Group. The Catalyst AV Group has 32 locations throughout the United States of the CDO Special. So why does everybody, or why does every integrator need to have some kind of a test kit for HDMI? If you guys have been following HDMI over the past few years, there's been some radical changes, and some significantly radical changes just in 2017 with the addition of high dynamic range, which has put some stress on our traditional distribution systems. So we need some kind of a tool that could troubleshoot these distributed systems. We also need to manage EDID. EDID has become extremely important in getting the signal to pass through distribution systems and extended distribution systems through multi-dwelling homes and businesses. EDID causes about 80% of HDMI failures, and we're going to learn about some tools to fix that in the presentation. Also, there's a new copy protection that has been required for all UHD content. So now you've probably found this out the hard way. Every component in the system has to be compliant. Any component that's not compliant causes the picture to go to basically noise. Also, now you need to be able to have an 18 gigabit per second reference signal source. What this enables you to do is basically cut down on truck rolls and redos, and gives you peace of mind as the owner of a business or as a technician. Why would you want to do on-site troubleshooting? With this kit, you can literally pinpoint the problem component. What typically happens, and I've been a technician myself for over 30 years in electronics, since we were replacing resistors and capacitors and transistors, is we tend to pluck and chuck when we don't have the proper tools and equipment. Pluck and chuck means we just keep replacing items until the symptom changes or until the problem gets solved. This costs money for everybody in the supply chain, including you. Time on the job. We get returned items that are not defective, and it just slows down the entire system. So you can save money and time by replacing only the products that have problems. You can identify system shortcomings overall, bandwidth issues, gotchas, etc. You can verify compatibility of system components before you put them in the system. And then you can also verify HDCP compliance throughout every component in the system. The main features in the Fox and Hound, which we have another generator analyzer that we've been selling for 2 or 3 years now, and some of y'all may have it, the 6A and the 6G. We basically took a subset of features off that kit and we put them into something that could be suitable for the field and affordable for the field. And what's left is a cable test, display setup and testing patterns, full 4K 60 444 test patterns, everything up to and including the HDMI 2.0B spec, HDCP testing, both 1.4 and 2.2, and the ability to turn HDCP off to test for connectivity on a system, full high dynamic range testing, HDR10, hybrid log gamma, and Dolby Vision, a set of EDID tools, and all this in a portable battery operated kit that comes in a nice ruggedized carrying case. 5 of the kind of like we came up with a 5-step troubleshooting process, and this is very general, 1,000-foot level, and we'll dig in as we go through the presentation today. But you can always reference this thing back to this thing, because troubleshooting, as anybody knows who's done it for a while, you can kind of start going in circles unless you kind of keep track of the process. So we made this 1,000-foot level process. You start at the source, you inject the desired signal through the path, the HDCP, the resolution, the timing, the chroma subsampling. You verify that you get a picture on the display, and then you move the generator to the next device in the chain, and you repeat the process. So you literally repeat this process through every component in the system until you have passed the defective component and you see the desired image. Once you see the desired image on the screen, then you can go back and re-inject the signal through every point, source, sink, and repeater, and pin down the actual problem component. We'll use the terminology source, sink, and repeater today. Source, sink, and repeater are common HDMI language. Source is anything that actually outputs a movie or a PowerPoint, like a PC or a UHD player. A sink is a display or a projector, and a repeater has both built in, such as an AVR or a matrix switch or a distribution amplifier, types of devices that can take an HDMI signal in and then have to either manipulate it or pass it straight back out. All right, so what brings us to this need to troubleshoot? You know, we've always needed to troubleshoot, but 1080p, quite frankly, was quite a bit easier to get through a category cable. Did not stretch the limitations of copper at all. We got a great technology that came out about 3 or 4 years ago called HD-Base-T. This cleaned up a lot of our extender problems with equalization and twists of the wire, etc. But now we've kind of reached the limitation of HD-Base-T. So we need a chart like this. We need to be able to calculate the bandwidth requirements to pass these high-value new movies in UHD and HDR. So we've put together this chart, which you can read yourself. We'll send you a laminated hard copy if you want it, just ask. But we also have this live on the Murideo and AV Pro Connect sites. You can go into our data rate calculator and you can plug in your resolution, timing, frame rate, bit depth, HDR, and you can get a number back that will tell you what type of infrastructure you need. This chart lists out our products. There are some of our competitors who are slowly coming to market with 18 gig products, but we pride ourselves in being first to market in this space. But if you kind of read this chart from left to right, you get the type, resolution, frame rate, color compression, color bit depth, high dynamic range, wide color gamut, and then you get the data rate. And so this is what's kind of driving the need for the Fox and Hound and the need for new types of components that can handle these high value signals. So the first test we want to do is a cable test. A cable test is the most basic test out there, and you'll be surprised how many of the cables you have laying around in your shop don't work anymore at 18 gig. You noticed in the previous chart the difference between 1080p and full 4K with UHD, HDR. You know, you're going from 4 gigabit per second uncompressed 1080p to about 18 gigabit per second at 4K. So significant difference. Significantly better engineering is required to make good cables, and you've probably noticed cables that actually work now are a lot shorter. No more getting away with red mirror or longer passive cables. So what we do here is to get this set up, we send a signal through the cable. We connect the cable between the generator and the analyzer first. We send a signal through the generator to the analyzer, any test pattern, just to make sure we have connectivity. And then we press the cable test button and we stop. This will take us through a complete test that you can read here. You know, we test the 5 volts, we test from 18 gig on down to lower resolutions. We check the DDC channel. This is what carries the EDIT information. We check hot plug detect, see if that's working. So we fully test the cable before you have to install it in the system. And when you're on-site troubleshooting and you suspect a cable, instead of swapping it, test it. And then you're 100% dead nuts on to get a good test. We have a question here. Had a cable pass 4K 60 but failed 4K 30. Is that normal during cable tests? No, it is not. It is not normal, but it depends on the additional numbers, like the 444. Or if he's talking about on our tool, um, it's not normal. I would try to swap out a like cable, and it should pass all the way down. And be sure, like it was pointed out in the previous slide, don't press any more buttons after you initiate the cable test, because that does tend to cause some kind of mixed results where you get a couple passes and then it starts failing or no signaling. Um, that can cause that also. But yeah, that's not normal. If it can pass 4K 60 or 18 gig, it should pass everything below. Okay. One of the other common items is timing and scaling issues. The first thing we want to do before, if you pre-rack, we think that's a fantastic idea. A lot of your brethren in the commercial space do pre-rack everything just so that they don't run into gotchas on site. We recommend that also. If you pre-rack, we recommend you use the generator in place of the source, select the resolution, color sampling, and bit depth that matches the maximum capability of the source. Um, so if it's like an Oppo UHD player, you want to select an output resolution, timing, and bit depth that matches the output of the Oppo. If you just want to test for maximum capability, press and hold the 4K button on the generator for 5 seconds, and it will automatically put the generator into the maximum timing, basically 17.92 gigabits per second signal, and you can run that through the system. At the other end, you substitute the analyzer for the TV, and you press info. Info will bring up information on the screen that shows what actual signal is making it through the system, including, as you can see on the bottom left here, the actual timing, frequency, color space, video type, HDCP version, color depth, bandwidth information, HDR metadata information, and audio information. So you get a quick snapshot of all the information on the signal, um, and it's very simple. If we flip back over now to video, we would actually get the video content coming through, just like we do on item 2 on this screen. We actually get the SMPTE bars, or the movie if you're plugged in live, and then we also get the full signal info, so we can evaluate what's going on and is the proper signal being passed through the system. Mainly what we're looking for is either no picture, or we're looking to see if one of those components between the television and the source has done something to the signal, i.e. has its own EDID management, has its own scaling setup. We want to make sure we know who's doing what in the entire distribution system, and this step in troubleshooting allows us to do that. One of the next things we want to talk about is HDCP issues. A lot of times, well, I would say in 2017, HDCP 2.2 in the television side has gotten very good. Where HDCP is still somewhat problematic is in some high-end AVRs or repeater devices, matrix switches, kind of custom AV products. The stuff we live with is where we see the most issues, because it is expensive to keep up with what HDMI, HDBaseT, and HDCP are doing and changing on a regular basis. We keep up with that on our products and our generators and analyzers to make sure that you have reference tools for testing in the field. So to do the HDCP test, we literally connect the generator in place of the source, choose any test pattern at the highest resolution your distribution system is intended to handle, and then press HDCP and select 2.2. Put in the analyzer at the other end and either select auto or HDCP 2.2 emulation. So you'll be emulating a device and how it acts in a system. Tip, at this time, you can also store a setting in the A, B buttons on the generator. This could be your favorite timings. You could have a full-blown 18 gig signal with HDCP 2.2 and SMPTE bars on A, and a 1080p pattern with HDCP 1.4 and SMPTE bars on the B button. So when you're troubleshooting, you can go through and push 18 gig and then down clock to about 5 gig and test if you can get a signal through the system. If you see the test pattern and the HDCP light lit, everything is good. 2.2 passes. If you get noise like you see in the diagram to the left, that means there's a problem. What that means is some component in your distribution system is not properly handling HDCP 2.2. And like I said, it's common in several components out there in the field today. Another note, you can also turn off HDCP completely for testing connectivity. So if you basically turn it off and then you get the SMPTE bars or the test pattern, you know some component in the system, and then you have to backtrack through the system and test each component for compatibility with HDCP. Okay, next step is troubleshooting source devices. And in the next 3 or 4 sequence of slides, we're going to tell you to use a trusted HDMI cable and a trusted CAT cable. What we mean by that, in your lab environment, use either the HDMI cables we supplied with the test kit and use a tested category cable that you know works. In our labs, I know we have 40, 70, 100s. We have all different sizes laid out so we can test and QA products here. But you should have some kind of a reference sample cable that you could use during all this testing, because you don't want your testing cable to be the thing that's causing the problem. So to test the source, we basically plug into the source with the analyzer. We just plug into the HDMI output of any computer, UHD player, anything with an HDMI output. We press info on the analyzer and we get the signals, and we see what that device is actually putting out versus what maybe it says it's putting out. And if we press the video button, we can actually see the signal on the source. Make sure that what comes out of the source is what you're expecting. A lot of times when you put some of these new streaming devices into a distribution system, they get really confused, they pull the wrong EDID, and you could be looking at a 1080p signal without HDR. So you want to make sure if you're trying to pass HDR, you're seeing 4K, you're seeing the right color space, you're seeing the right bandwidth, and you're seeing the HDR metadata present on the analyzer. If everything reads correctly, you know that everything in the system is going to work. If something isn't optimized or something is running at 1080p, you're going to need to correct it. Or what can happen is it can downclock everything in the system. Troubleshooting sync devices or displays. With a display device, what we're basically doing is we want to eliminate the display as being the problem. Most displays, there's not a lot of problems. Projectors, high-end projectors, using kind of obscure processing equipment, that's where you tend to find issues and problems, and you want to be able to have a known entity. You want to know what you send into the display is what it can react to and present back onto the screen. There's that tip again on loading in the maximum rate, just the method of doing it, 5 seconds on the 4K button, and it puts it into the maximum rate. You can press color on the generator to set the chroma subsampling and bit depth. For a maximized UHD player, you should set this up at 3840 by 2160, 24 frames per second, which is basically the film-based rate for frames, and then 444 12-bit. The test pattern should appear on the display. If it does not, decrease the bandwidth until you get a picture on the screen. Once you get a picture on the screen, that is basically the maximum resolution that television can accept. Troubleshooting repeaters. Repeaters have an HDMI input and an output. So this time you need two HDMI cables. You plug the generator into the input of the repeater, or the input of the AVR, or the input of the splitter, and you plug the analyzer into the output, and you basically test as you would a source or a display. You're just testing both at the same time. If everything is working properly, there should be no alteration in the signal unless you want it. Some of these devices in the middle of a distribution system do have EDID management and scaling. You just want to know what's going on, where the scaling and the EDID management is taking place. So this is a very good time to be able to have separate units, because sometimes this is going to be distributed at a long length in a building or a facility. Troubleshooting extenders. Extenders are the lifeblood of the custom AV industry for extending HDMI cables. This has become more of a challenge lately. If you get a chance, you may want to check out the AV Pro Connect 444 extender sets and new HD-based receivers that actually do some light compressions to make this happen through copper. But there's extenders that use copper, there's extenders that use fiber. You can test them all with the Fox and Hound. Literally, this is where the trusted category cable or fiber optic cable comes into play. And we do the same exact process. We inject into the transmitter, and we connect the analyzer into the receiver, and we check for max bandwidth or max rating on that device. With normal HD-based T receivers and transmitters, this is going to be maxed at about 10.2 gig. And normally that relates to about 8.9 in the world of actual recognized formats in HDMI. So reference back to the data rate calculator or the timing chart when you're testing components, or you'll notice it if you threw 18 gig into a HD-based T extender, it's just going to fail. Select the info button on the analyzer to read what is being output. It should be the exact same as what you see or you sent in via the generator. You can go through and quickly dumb it down, use the AB switch to dumb it down or downclock it so you can possibly get a lower bandwidth signal through the system. That way you can verify that you don't need to re-terminate the category cable, or you don't have some kind of a defective category cable with an open somewhere in the system. You can also at this point toggle HDR on and off to determine if the extender can pass HDR 10, 10 plus, or Dolby Vision or hybrid log gamma. Don't forget to check the standard HDR formats in the HDR troubleshooting section that we'll get to here in a second. All right. So we are at HDR troubleshooting. HDR now, if you have not seen HDR, see it. Go see it. Like personally, I've replaced my Pioneer Kuro Plasma finally about 6 months ago with an OLED that is capable of HDR, and it's just fantastic. It is a night and day difference in improved luminance and improved blacks. So you do want to provide that to your customers going forward. And if you've kept up with the press and the media, HDR has really made an incredible and significant improvement on the sale of this type of television. And it literally, 4K was nothing compared to HDR. HDR is a phenomenal thing. So you need to troubleshoot it. You need to make sure your distribution systems can pass it. So what you want to do, you want to send in 4K 60, 444, 8-bit. That tests the full 18 gigabit throughput. Normally, if the system will handle that, it will handle anything. There are a couple exceptions. You also want to test with 4K 60, 422, 12-bit. 12-bit 422 60 is what Roku, Kaleidoscape, and the new Apple TV that will be coming out in 3 days will be able to do. Apple TV just announced this with the iPhone X, and this new box will also do HDR10 and Dolby Vision. It is something you're going to want to put into your customers' homes, and we're excited to see that. It is already tested and compatible with all of the AV Pro Connect and Murideo products, as we have been working with Apple on this new Apple TV that's coming out. So all the testing has been done, and everything in our infrastructure offerings does work. The other one you want to test is 4K 24 or 30 at 444 12-bit. This is the HDR film timing that is unlike your Oppos, your Panasonics, and your Samsung players. Traditionally runs at about 14 gigabits per second at the moment. It is, extremely important that you check these signals through the systems, through the repeaters. A lot of times the repeaters are the culprits that destroy this format on the way to the display. So you want to test everything in the system to make sure it can handle HDR. If your system can handle it, then you have installed a robust, stable, high bandwidth signal that will work great for your customer for many, many years to come. You might have heard some talk about this 4K or this 4K 30, 420, 10-bit HDR, this 9 gigabit signal. This is a myth. It is HDR UHD is encoded on the disk in this format in post-production. However, it is not supported by any sync device that we know of. In lower frame rates, 444 is required for it to work. Do not be fooled by this. Because what we're saying there is there's some HD-based TV manufacturers are talking about they can handle this format. Well, that's great, but there's no TVs that can decode it, so it doesn't make any difference. I think there's confusion because inside the Oppo, you can look at the actual format of the disc, and then you can also look at the output format of the device, and that's where that format shows up. And it is basically just the format that's used to get the information stored on the disk. You must also check HDCP 2.2 because if that's not there, HDCP or HDR is probably not going to work. So make HDR your friend. There's plenty of solutions that we have through AV Pro Connect. There's also fiber optic products on the market now that are capable of passing the full 18 gig signal. The AV Pro Connect group will be coming out with a fiber extender in about 4 weeks to go along with our Clearline fiber field terminatable offering. So look for that. That will have also complete control capabilities on it, plus audio return channel. Then the thing we talked about at the beginning was EDID. I know there's a lot of words on this slide, so I'll try to make it as not boring as possible, but EDID does cause about 80% of the problems in HDMI distribution systems. If you have good connectivity, then it's down to how does the EDID get processed through the system. Basically, EDID is an extended display identification device or data that actually is a communication from a television to a source. The display sends the EDID to the source. If you were to verbalize EDID communication, it will go something like this. Hello, I am an LG XYZ TV, and I would prefer that you send me 1080p, and you can kind of read the rest in the middle. So there's a communication that goes between the display and the source to attempt to get the correct resolution, but more importantly, to just get a picture and audio out of the system. So a lot of the consumer devices that are out there that your customers are very familiar with, Roku's, Apple TVs, etc., a lot of times those do some robust EDID manipulation just to get a picture on the screen. And a lot of times that means a picture with no HDR and uh, and at 1080p. And I'm sure some of y'all have seen this and kind of wondered what the heck is going on. Some component in the system is not functioning properly, and typically it's like EDID spoofing or an EDID that's trying to downclock to get a system to function. You probably use EDID management devices in your everyday life to get things working. I know we put inline EDID management in all of our matrices and our new extenders so that you can kind of work with the EDID to get the signal to pass through the system. Common reason you need to pay attention to EDID: sync devices all use lower bandwidth EDID to ensure a picture on screen. Repeaters or splitters, this type of thing, they will often spoof the EDID to force the source to give something that is compatible for and not necessarily what you want. So in other words, make a picture on the screen. To test this, it's really easy with the Fox and Hound. Simply place the generator into auto EDID mode and check what the generator sets itself to. And when you do that, basically you're able to read the actual EDID that's in use. And you want the EDID that's in use to be the EDID from the TV, not the repeater, not the AVR, unless you forced it in there yourself to correct some kind of an issue. But that is a very common thing that happens. Some downstream component in line with the AVI distribution system pulls the wrong EDID, and then we are not able to get picture, sound, full bandwidth, or high quality signal through the system. So test it with the auto EDID function and note which EDID is being utilized, and then go through the system and either put these different EDID management devices or matrix switches into a bypass mode, or carefully integrate EDID management as necessary in mixed systems, multiple manufacturers, multiple video timings and formats. It is all doable and correctable with EDID management. But you need to know who's using what EDID, and you could do that with the Fox and Hound. So now a little bit more on common problems in distributed AV systems. No video is number one, I'm sure. You get no video, you just start scratching your head. And this is where most of the pluck and chuck starts happening. You start rebooting things, disconnecting, reconnecting cables. But if you use a systematic troubleshooting process like we talked about in the beginning of this presentation, you can quickly eliminate defective components quick and then get down to actually what needs to be fixed, replaced, or adjusted in the system. No 4K. This is typically because the EDIDs are not being managed properly in a repeater or a sync. So you must go through the entire system and make sure every component in the system passes the full bandwidth signal you're trying to get through. Incompatible video. Incompatible video is when you get the message on the screen that says this is like an invalid format or the TV does not support it. If you know that the TV or the sync device should be able to handle the signal, strip the EDID out and make sure the rest of the setup is ready for the same EDID. So what you do with the generator, when you have a generator, you basically are bypassing all EDID. So you can basically test the signal, I call it raw. What you send out is what the TV should be able to decode. So you can literally test every HDMI 2.0 B and every VESA format and see if it will pass through that system. And if it does with the generator, then you know some component in the system, when you reinsert it, that's what's causing the problem. And that's what needs to be either replaced or adjusted. Discolored video. Check the settings on the sync to make sure it will show the correct color. In other words, is it decoding RGB or is it decoding YUV? This is a color space mismatch. It's common especially in several projectors, some higher end TVs, where they sense the device being connected is a PC versus a UHD player, and they run it into RGB or PC mode, and that's where you end up getting a color space mismatch. And what that typically looks like on screen is either a pink screen or a green screen. We've all seen that. Source problems. Again, you can test source problems directly with the analyzer and just make sure what you want to push through that system is what is actually coming out of the source and directly into the analyzer. That's also a good way to maximize that source and see, what is its maximum output timing, resolution, bit depth, and HDR setting. A lot of times those things get put into auto mode. Auto mode means leave it up to the EDID. Okay, so that comes to the end of our presentation. If you have some questions, now's the time to ask. I'm going to unmute everybody here in about 2 minutes, but I did wanted to put up the Catalyst AV territory map so you can see we do have locations throughout the country. And you can also call in directly to one of our regional sales managers here at AV Pro Connect and Murideo in Sioux Falls, South Dakota. And they'll be glad to help you out. As this person is finding that 5-foot cables work fine, and they test out fine, and 50-foot cables do not. Well, 50-foot is roughly 50 divided by 3 is like about 15 meters. So 15-meter passive cable that actually worked would be a rarity. So yeah, that's going to probably fail the cable test, and it's probably going to have a very high bit error rate, and it might work sometimes, and I wouldn't depend on it. I would go with AOC, which is an active optical fiber cable, or go with some kind of a new, like our new 444 extenders over category, where we do some color compression in the middle, but it's visually lossless. But yeah, 50-foot is pushing it for a passive cable. I'm going to go ahead now and unmute everybody. So if anybody has any questions, you can ask that way also. Okay, so is there additional detailed training for techs in the field? Absolutely. There's a couple things you can do. You can call your regional sales manager here at AV Pro Connect or Murideo, and we will be happy to provide you with some additional training. We are completing an HDMI field guide as we speak. It's about a 50-page HDMI troubleshooting document that will be available both online and in print within the month or within the next couple weeks. We have also reorganized the ISF course. Imaging Science Foundation Level 3 is in the midst of being created and tested here in Sioux Falls in late October, and will be launched at Sony in San Diego. So Sony San Diego is launching the first ISF Level 3 class that will include HDMI troubleshooting, HDMI 18 gigabit switch setup and distribution. So a day and a half of actual getting the HDMI signal to the party, and then a day and a half of traditional ISFing televisions and projectors, calibrating via HDR. One of the latest revelations that started to happen now is Samsung, Sony, and LG have all made their flagship products available to us to talk directly to their firmware. So the newer versions of the CalMan software now can automatically calibrate like the flagship QLED and OLED televisions on the market. You can ask your regional sales manager for more information on that. But yeah, we can definitely provide more additional training. So the question was, what is the shortest cable that a cable test would be relevant? Anything that's probably 1 to 2 meters, you can pretty much be confident in it if it's connected between the source and the sink. Anything above that, I would probably test it, especially when you get to 5 meters. 5 meters and above, I would test it just to make sure. We've seen problems in 5-meter cables. We've seen a lot more problems in 8-meter cables, and more than that in 10 and 15-meter passive cables. A 15-meter passive cable almost has to be engineered flawlessly in order for it to pass the test with a limited amount of bit error rates. Okay, so the question was, when you're testing HDCP 2.2, what do you do with the generator and what do you do with the analyzer? So let's talk about that. So the generator is, if you put that into HDCP 2.2 mode, that means the signal it's outputting will be HDCP 2.2. And it can accompany on the generator a 1080p signal or a 4K signal or whatever. But normally that's used with 4K. The analyzer has to be either set up to emulate a television. So think about it like that. So you would want to set the analyzer up to either HDCP 2.2, so that's the direct path, or auto. And auto, it should be able to go into 2.2 or 1.4 automatically based on seeing that signal from the generator. And also, if you wanted to test the entire system with HDCP off, you would turn it off on the generator, and then you would turn it off on the analyzer. So you want to kind of make those things match up unless you're trying to cause a failure. In other words, unless you're trying to see how does the system react. If I send it 1.4 and I have 2.2 should work. If I send it 2.2 and I have it on 1.4 emulating a 1.4 TV, then you should get noise. We'll be doing these webinars monthly, so look for the lineup coming down the pipe. Appreciate your attendance. Thank you very much.